Great, so this is going to be why lattice multiplication works, and this is a video extra for my kids at school and a video for my friends, my imaginary friends on the web. Okay, so let's first talk about how traditional multiplication looks, what we do when we're doing traditional multiplication, which is multiplying mostly vertically. Actually, I don't want to do the 12 first. On all the examples, I did the 15 first. And I just started with a nice small, too small, but two-digit. You know, you want to use two-digit numbers for this lattice thing. And I didn't learn lattice multiplication until I became a teacher, just so we're clear on that. Let's remember what multiplication is. So first think about the concept. So we're finding what 15 12s is, or what 12 15s is. Either way that you want to look at it. And the way that we learned how to do this, and when I say we, I mean our generation. I can't call myself a millennial. What did we say we are? Generation Y? I don't know, whatever. The way that we learned this back in the day is we learned to start off by multiplying the ones digits. That's 2 times 5, that's 10. But you don't write down 10, you write down a 0 and you carry a 1 over, because the tens place is the second place value place. Then we learned to multiply the ones by the tens, 2 times 1 plus 1 here. So that comes out to be 3. Okay, then we learned, now we go down here and we multiply this 1 times this 5. But the problem with this method starts here. Okay, you can say that it starts here, you know, as long as you're trying to teach students that you, or children, that you've got 2 times 15, please excuse my cell phone, 2 times 15, and that makes 30, then that's good. But it's also important that you start thinking in this next step, where it's this 1 times this 5, that this is not a 1 times a 5. This is a 10 times a 5. And that's one of the first things that kids will come to me and go, wait, what? That's a 10? No, that's a 1. No, guys, it's a 10. It's in the tens place. So this is where this method has a breakdown. Let me finish it anyway. Okay, we learned to, now we multiply this 1 times this 5, and down here we leave a space, and sometimes you're taught to put a 0 there. Some kids put a happy face there. I've had kids put an X there. So 1 times 5, 5. And then finally, 1 times 1, which is not 1 times 1, it's 10 times 10, and putting a 1 right here. For 100, really, is what it is. So the product of 15 and 12 is 180. So before we get to the lattice multiplication, let's think about this concept and let's break it down a little bit, because that's going to get us to why the lattice multiplication works. Okay, so 15 times 12. Let's think conceptually here. The first step is 5 times 2, and that's 10. Okay, the second step is 2 times this place value of a 1, which is really a 2 times a 10. And 2 times 10 is 20. And see, this is the way my Grandpa Nugent taught me to do this. He taught me how to do this multiplication. He taught me how to do basic math conceptually, which was awesome. And I think that's absolutely, actually a lot more of what good teachers did way, way back in the day. You know, Great Grandpa Nugent was born in 1910, so he was learning this stuff in the 20s. Okay, anyway, continuing. 2 times 5, 10. 2 times 10, 20. Now it's 10, because this 1 represents a 10. It's in the tens place. So that's 10 times 5, that's 50. And then finally 10 times 10, that's 100. So if you look at the way that that comes out right there, that's the same thing that we just did, except with that carrying nonsense. And see, that carrying stuff gets confusing for kids because it seems arbitrary. They don't understand why they're doing it. Okay, let's break this down further and look at it in another way. And for my students, this next part should remind you of something we've learned in class, and I'll bring it up in this next scene. Well, slide. Okay, so again, 15 times 12. Let's think about 15 as 10 plus 5, and let's think about 12 as 10 plus 2. And let's break them apart, and let's recognize that actually what I'm doing here, just like I did on the previous slide, is I'm multiplying the 10 times both of these 10 and 2, and the 5 times both these 10 and 2. So that's the entirety of 15 times the entirety of 12. And let's look at how this came out. Well, 10 times 10 is 100. 5 times 2, that's 10. That's down here. 5 times 10, that's 50. And then 10 times 2, that's 20. And if I want to go through and add those up, I once again get 180. Which is the product of 15 and 12. Now, my students, what does that look like? What does that remind you of? What is that? Looks a whole awful lot like FOIL, don't you think? So we can actually introduce FOIL when we introduce double-digit multiplication. And that's the difference between learning algorithmically and learning conceptually. Now, finally, we get to the part about lattice multiplication. So the color coding you should recognize, because part of this we actually just used on a previous slide. And I'm going to bring that image in just a second. So lattice multiplication has you put one 2-digit number, or you can do bigger values, and that's fine, but I'm just doing 2-digit times 2-digit. One number across the top, one number down the right-hand side. And as you draw a box, and then you put these diagonals in, these lattice values. And then you take and you multiply, so 5 times 2 is 10, and we put a 10 right here. The 1 in this top half and the 0 in the bottom half. 5 times 1 is 5, and we put a 5 right here in the bottom half and a 0 in the top half because it's just 5. 1 times 1 is 1, so 0 and 1. And 1 times 2 is 2, so 0 and 2. But what you're actually representing here is the same kind of stuff we just did in the previous two examples. This is not really a 1 times a 1. This is a 10 times a 10. Podrick, stop. The cat is sitting underneath the bed I'm sitting on, scratching at the wall to get my attention probably. Anyway, this is a 1 times a, is not a 1 times a 1, it's a 10 times a 10. So when I put this 1 in this spot, what I'm really doing is putting a 1 in the hundreds. Because if you look at the diagonals, this first diagonal is the ones place. Ones times ones gives you ones. And the reason that you have the top half is that if you get to a 2-digit number, that's no longer a ones digit. It goes in the next place value place, which is the tens digit. So this diagonal is the tens. This is the hundreds, and if we had any, this would be the thousands. And then when you add down the diagonals, so 0, 5 plus 1 plus 2 is 8. 0 plus 1 plus 0 is 1. And then, of course, the 0 at the top here, I'll just write it in for good measure. You get your answer, which in this case, the 0 means nothing, so 180. And again, like we've already seen several times, 15 times 12 is 180. Okay, so to finish up, let's again look at what we're talking about here. So I'm going to move this a little bit. Look at this one. You see how the place value colors match? This is the ones. This is the tens. And then this is the hundreds right here. And of course we don't have a thousands place, but I went ahead and color coded it just so I could use my fun little highlighter tool in the Notability app. So I hope that explains, I hope that clears up, and if you don't feel like it does, tell me and I'll make an addendum, but I hope that clears up the whole issue of why lattice multiplication works. Thanks for watching.